Yeah, dear students, now I will start new topic here in this video, refraction through lenses or lens maker formula. This is very important for understanding the action of lenses. Suppose I take here a double convex lens whose radial curvature are R1 and R2, and this is the principal axis here of this lens. Pole P1, P2. Suppose I place object here, point object on principal axis. The ray will go straight. Now I take another ray here. It gets refracted like this. Here is the normal, bend to the normal, and it should have gone like this if there had been glass throughout, but there occurs second refraction on second surface. This refraction here has taken on first surface. Again we are going from glass to air. Normal will be this side, it will further bend toward normal. So finally it will appear, it will really meet principal axis at this point, and here I will be the real image. Please try to understand. It is double convex lens with two surface area curvature R1, R2. Point object placed on principal axis. Ray along principal axis goes straight. It taken another ray at surface 1. There occur refraction from air to glass, so it went toward the normal. Now at surface 2, so if surface only this and glass had been there, the ray would have met principal axis at this point. But again, the glass is not there in second surface, light going from glass to air, it will bend away from normal. The normal of the surface this way. Our eye will see what? I only. Let I mark here P1O equal to U, P1, P2, thickness of lens T, P1I dash equal to B dash, distance of image I dash from surface 1, and P2I dash, it will be B dash minus T. Actually for second surface, for refraction second I dash will act virtual object, and P2I equal to B. In exam you can draw the diagram. After a little explanation, point O object is there. Due to refraction on first surface, ray would have meet principal axis at I dash if had been glass, but on second surface, please make this reflection here, second surface. Students are very careless in drawing diagram, and diagram in board exam, so there are 15, 16 marks or sometimes 22 marks diagram questions are there. So please practice diagram neatly and label them. So using refraction formula, what is it? N upon B minus 1 upon U equal to N minus 1 upon R for first surface. We get light going from glass to the nth stage, N upon B dash is the distance. minus 1 upon u is equal to n minus 1 upon r. At second surface, light is going from glass to air. And for this refraction, I dash is the virtual object. So from a refraction formula, light going from glass to air, so n in place of n we use 1 by n upon image distance v minus 1 upon p to I dash with the distance of object p to I dash. It is v dash minus t. V dash minus t is equal to 1 upon n minus 1 upon r. By refraction formula हमारा है n upon v minus 1 upon u equal to n minus 1 upon r. Here I have taken 1 by n in place of n. Why? Because light is going from glass to air. For thin lenses, T is negligible. So this equation can be as, and multiplying by n, we get, if we multiply it by n and neglect t, we get 1 upon v minus n upon v dash is equal to 1 minus n upon r2. यहाँ r1 sorry बच्चों, sorry भाई, r1 here r2. Now add equation 1 and 2. This is equation 2. This is equation 1. Adding 1 and 2, n upon v dash cancel. Now adding equations 1 and 2. We get 1 upon v minus 1 upon u is equal to, here it is n minus 1, it is 1 minus n. I take n minus 1 common, 1 upon r1 minus 1 upon r2. Equation 3. Now here is very important discussion. By finally we get equation 3 as 1 upon v minus 1 upon u is equal to n minus 1 into 1 upon r1 minus 1 upon r2. But we want to relate focal length of lens, this is equation 3 here. We want to relate focal length f, small f, with the reflex and radial curvature. Some people directly write that we know 1 upon v minus 1 upon equal to 1 upon f. No, that is wrong concept. That is totally wrong concept. Here in equation 3, from definition of first focus. Remember, first focus था point on principal axis from which diverging beam become parallel or beam converging to it become parallel to principal axis. Means if object is placed at first focus, प्लीज सी आई टोल्ड यू कि इट इज कॉन्वेक्स लेंस, तो यहाँ से जो रे चलती थी पैरेलल हो जाती थी वो, इट मीन्स इफ ऑब्जेक्ट प्लेस एट फर्स्ट फोकस देन इमेज विल बी एट इंफिनिटी इन कॉनकेव. अगेन दिस पॉइंट एक्चुअली फॉर कॉनकेव सरफेस, कॉनकेव लेंस बोथ द फोसाई आर वर्चुअल पॉइंट become parallel, so it will be virtual object. Object places first focus, then image is at infinity. So using v equal to infinity and u equal to f1 in equation 3. F1 is focal length of first focus, the distance of first focus. We get क्या मिलेगा? 1 upon infinity minus 1 upon f1 is equal to n minus 1 into 1 upon r1 minus 1 upon r2, or 1 upon f1 is equal to minus n minus 1 into 1 upon r1. This is the distance focal length, reciprocal of distance of focal length is this, minus means for convex surface both this r1 positive r2 negative, so it will come negative means this side, and here it is negative positive, so we will put, then it will come this side. First focus, equation 4, very important. Now from definition of second focus, if remember if object at infinity, तो इमेज फोर्ड फोकस सेकंड फोकस है भाई. तो u from डायरेक्ट फर्स्ट फोकस, if u is equal to infinity, v is equal to f2, so use equation 3. So from equation 3, 1 upon f2 minus 1 upon infinity n minus 1 into 1 upon r1 minus 1 upon r2, यानी कि 1 upon f2 n minus 1 into 1 upon r1 minus 1 upon r2. Equation 4 and 5 are indicating that distance of first and second focus are equal here. Minus sign here indicate from equation 4 and 5. F2 is equal to minus F1. But this condition applies only when medium on both sides same. If medium on both sides of lens is same, then you can write here, if medium on both sides same, बट माइनस साइन के अपोजिट डायरेक्शन होंगे. इसका ये F2 है तो F1 इधर, इसका F1 यहाँ तो F2 इधर. इसके केस में क्या था कि पैरेलल रेज appear to diverge from focus. But which equation should we use while finding the focal length? By definition of lens, converging lens. Which converging lens? Rays parallel to principal axis converge at a point on focus. Sorry, converge at a point on principal axis, which is called second focus. Diverging lens, rays appear to diverge from second focus. Due to converging or diverging nature of lenses, we use second focus. Of lenses. So, dropping suffix 1 and 2, dropping 1 and 2, we can write 1 upon f equal to n minus 1 into 1 upon r1 minus 1 upon r2. This is called length maker formula. Lens maker formula. तो focal length of any lens, converging or diverging, depend on index of the lenses and radial curvature and independent of क्या भाई कुछ भी नहीं. You can't say कि f equal to r by 2 here. Why? Because if suppose we have equiconvex lens n equal to 1.5, equiconvex, means r1 is equal to r or r2 is equal to minus r and 1.5, then 1 upon f equal to 1.5 minus 1 into 1 upon r minus 1 upon minus r. So 1 upon f equal to 0.5 into 2 upon r. So f equal to r. Actually, in spherical mirror, focal length f was r by 2, here you are. Or if we, in place of this, we have plano-convex lens, so R1R, R to infinity, R1R, so it will be 2R, f equal to 2R. तो प्लीज 1/f is equal to n minus 1 upon into 1 upon r1 minus, if it was equiconvex lens or index n ही ले लें, and it is cut into two parts perpendicular to principal axis. So what is the focal length of each now? N minus 1 into 1 upon r minus 1 upon infinity. If I divide f dash upon f, क्या बचेगा? वो था 2 by r. If r1 is equal to r, r2 equal to, है ना? तो क्या मिलेगा यहाँ? You will get it 2. तो f dash equal to 2f. Actually focal length reduce हो गया. Increase means it become less converging. But if we cut convex lens along the axis, then focal length of each part will remain same because r1 and r2 are the same. But if cut along the perpendicular axis, it reduced and become half lens. यानी कि converging ability or diverging ability will be reduced. In next video, I will be coming with more information for this lens.